Hi everyone, welcome back to another week of Biology 1124. This week we'll be looking at yeast metabolism. But before we get into that, I wanted to go over a couple of things regarding lab summaries. So the first thing is that we are adding a new section to the lab summaries. It'll be before your introduction section, and this is just so that we make sure that you're thinking through the experiment before you get started writing and analyzing it. So in this section, it'll be a pretty quick section. You just have to list your hypotheses, the independent variable, the dependent variable, the control groups, and the experimental groups. So it doesn't need to be full sentences for these other than the hypotheses. You just need to quick and dirty list what needs to be looked at that week. I also wanted to go over hypotheses again. So this is something that will take some work throughout the semester probably, but hypotheses need to be causal statements, and so these are statements that establish a cause for the observed phenomenon. I think I mentioned this in a couple people's lab summaries last week, but they need to include the word cause or because. And so the example that we gave the first time around was that bee populations have declined because of insecticide exposure. So just make sure that when you're coming up with your hypotheses, you're not just giving your prediction, you're explaining why you think that's happening. I also wanted to go over graphing. So in these labs, you're typically not going to get an explicit make a line graph or make a bar graph or whatever that is. But what you do need to make sure is that your graphs, however you decide to do it, demonstrate what you actually were observing and measuring in lab. So typically the dependent variable is going to go on the y-axis and the independent variable is going to go on the x-axis. And so sometimes that will result in a line graph. And remember that line graphs, when you're measuring things over time, is typically what you're going to do. And also remember that on the same graph, you can put multiple groups as long as there are ways to tell them apart. So color, line, width, like dashed lines and stuff. So just make sure that when you're graphing, the kind of graph you pick makes sense. Bar graphs are usually going to be for categorical variables. Line graphs and scatter plots are going to be for time. Those are just a couple trends that usually will happen, but just think through how you're graphing these things. And if you have any questions or you're unsure about your graph, send me an email or come to my office hours. So this week in lab, we're going to be designing an experiment. So you guys are going to actually play a role in what you are measuring and what you're actually doing. You're going to watch the experiment, collect your data, and make a graph, and then you're going to write a lab summary. And of course, the weekly Flipgrid video. So as I mentioned before, this week we're going to be looking at yeast and its metabolism, and so why they metabolize some sugars at a different rate than others. So it's important to remember that, like so many different biological phenomenon, we're going to be thinking about these in terms of enzymes and enzyme activity. And so one really important thing about enzymes is that, one, it takes time for an enzyme to do something. When you think about these things, they're just kind of like cells are just sort of vats of random molecules flying around, and so it takes time for an enzyme to actually run into the substrate that it's going to act on. Another thing to keep in mind is that enzymes are very specific. So typically one enzyme will only have one or two different things that it can bind to. And so in this case, if an enzyme is going to be breaking something apart, it has to be the right thing that it's going to fit into the active site. And so take that into account as you're thinking through today's activities, because it'll be really important for the conclusions that you can draw at the end of this. So if we were going to do this in person, you would be using these CO2 probes, and because these are going to be working on very small scale changes in CO2, it would need to be set to low, and you need to make sure that it has time to warm up. These probes need to stay dry, so if you ever end up using a CO2 probe in the future, it'll need to be dry, so don't let it get wet. So this is specific to this lab, but also specific to a lot of general labs. You can't always just hook up the machines, let it run, and then blindly take whatever reading it gives out. You'll need to be thinking about if it's an appropriate level for what you're researching. And so this can be tricky because sometimes you're starting a new protocol and you're not sure what is the case, but for these labs, an appropriate ppm or parts per million is going to be between 350 and 800. And so you guys probably won't have to worry about this because it's a pre-recorded virtual lab, but just keep that in mind. So because this lab is virtual, you guys will be watching Dr. Shaw go through the protocol, but be aware that they had to set up the sampling regime on the logger. You're only going to be using the last 10 minutes of each trial, and this is because it can take some time for these enzymes to start working at a constant rate, like that you can see in the image that there's a curve in the beginning, and you want it to be a pretty linear trend, and that'll be the trend line that you're adding for the rate of CO2. So if we were doing this in lab, as the experiment was running, you would be able to be like writing and doing stuff as the experiment was running. Make sure that you know how to use the software that you'll be using. And yeah, this slide is more relevant to those doing it in person. When you use these kinds of expensive equipment, you have to be very careful. You have to wrap up the cord and put it away, but not too tightly because you don't want to damage any of the internal wires. And again, you need to be clean while you're doing everything. You will be looking at several different trials, and the trials in this case are different combinations of sugars and the same yeast cultures. So this is again where you'll need to think about the control groups, which one of these would be the positive or negative controls. Your experimental design is absolutely going to be using these three solutions. And so remember that we're looking at metabolism, so we're looking at the breakdown of these complex or more complex sugars when you're thinking about the positive and negative controls. So you're also going to be, this is where you get to play a role in the design of this experiment, and you'll be choosing between lactose or raw sucrose. And so when you go to download these data sets or experiments, make sure that you're choosing one intentionally. You don't have to do both, and I would really encourage you to not waste your time doing both. But you'll need to think about it. You have lactose, which is milk sugar made from glucose and galactose. So this is a specific combination of those two monosaccharides. Or you have raw sucrose, which contains molasses, extra sugars, vitamins, minerals. It's got a lot more, it's a lot more complex of a solution that you would be making. So again, just choose one of these and be able to explain why you're interested in comparing it to these other experimental groups. So this research proposal is really what we're adding to the lab summaries. So this basically would be your research proposal. You would normally have to have it approved and then you would start, and so that's why I'm going to encourage you to work through this first section, the experimental design section, where you think about your hypotheses, your variables, your control and experimental groups. Think about it before you get started with the video. You don't have to, but it's going to make it easier. And then like every week, these are going to be due at noon on Friday, in addition to the flip grid summary, which I'm going to include in the notes of this YouTube video.